Welcome to our lecture online, and here's our next test question, so to speak. We have a liquid that has compressibility equals to K and a volume and coefficient of expansion equal to beta per centigrade degree. Now the question is, what is the change in the pressure when the liquid is heated, amount delta T centigrade degrees, and is prevented from expanding? And let's only worry about the magnitude so we can ignore the sign. And here are the possible answers. Which one will it be? So they're asking for pressure. Now pressure is force per unit area. It's also stress. Because remember, when we have the bulk modulus, that is by definition equal to the stress divided by the strain. And the stress essentially inside the liquid is the pressure inside the liquid. So it's equal to the pressure divided by the change in the volume over the original volume. And the bulk modulus, by definition, is 1 over the compressibility. So now we have a relationship between the compressibility and the bulk modulus, and the bulk modulus and the pressure and the strain, which is the change in the volume over the original volume. So let's go ahead and solve this portion first. So we can say that the change in the volume equals the original volume times the coefficient of volume expansion times the change in the temperature. And so if I now divide both sides by V sub naught, I get delta V over V sub naught, which is the strain, is equal to the bulk modulus times delta T. Now it's a funny looking beta, so let me try that again. There, much better. All right, so that means if I want to know the pressure is going to be equal to, if I take a look at this equation right here, I want to solve this for pressure, I can say that the pressure is equal to the bulk modulus times the change in the volume over the original volume. So this we already have. Now the bulk modulus is 1 over K, so that means that the pressure is equal to 1 over K times the change in the volume over the original volume. And so therefore the pressure is equal to beta times the change in the temperature divided by the compressibility. And so let's see if the correct answer is up there. And let's see, beta delta, that's this one right here. And so answer B is the correct answer, and that is how it's done.